Hello friends, today I will discuss another important laser, that is Nd YAG laser. Construction, working and uses. Introduction. Nd stands for neodymium and YAG for yttrium aluminum garnet. Nd YAG is a solid state laser. It is a 4-level laser and it is developed by these scientists in the year 1964. Construction. First of all, I want to tell that the construction diagram is almost same as the ruby lasers, so you can neglect this ruby rod and you can write down here as Nd YAG rod. The rod of Y3Al5O12 is topped with 1% with triply ionized neodymium. Nd3 plus ions will replace the Y3 plus ions in the crystal. Maximum length of the rod is about 10 centimeter and diameter is 6 to 9 centimeter. Actinidium. The neodymium ions act as actinidium or active centers. I have discussed about actinidium or active centers in the previous video lectures. YAG is just the host, pumping source. The pumping of neodymium ions to upper levels is done by krypton arc lamp. Xenon lamp can also be used as pumping source. We have used xenon lamp in the ruby laser. Thus, the optical pumping is used to achieve population inversion. Optical resonator system. The ends of the Nd YAG rods are polished and silvered so as to act as an optical resonator system. To study the optical resonator system, please refer my previous video lectures. I have discussed in detail. Working. Nd YAG is a 4-level laser system. The pumping of neodymium ions to upper state is done using krypton arc lamp. That's with the help of pumping source. Thus, optical pumping is used in this laser. The wavelength of light of wavelength 7200 angstrom to 8000 angstrom excites the ground state E1 neodymium ions to E4 states. From E4 states, they make a non-radiative transition and come to E3 state. E3 is the metastable state, so population inversion is achieved between the levels of E3 and E2. So here you can make the construction diagram, the working diagram. The working diagram is same as the ruby laser. So excitation from E4 to E1 to E2, from E1 to E4 with the help of pumping source. Then there is the transition, there is emission from E4 to E3, E4 to E3, and population inversion is achieved between levels E3 and E2. Thus E2 will be metastable state. So this is a non-radiative transition and the population inversion is achieved between here to here. Okay, and from E4 state they make a non-radiative transition come to E3 state, and E3 is a metastable state. E3 is a metastable state, so population inversion is achieved with the E3 and E2. After this, process of stimulated emission will occur. I have already explained the process of stimulated emission in detail in the previous video lecture. Thus, the laser emission will occur in between the levels E3 and E2 with the process of stimulated emission. So E3 is the upper laser level and E2 is the lower laser level. Then neodymium ions come back to the ground state E1. Note down, please, the diagram is same as the ruby laser. Only difference is that in ruby laser I have used the bands. In this laser, the transition is from E1 to E4, then E4 to E3, population inversion between E3 and E2, so laser is achieved between E3 and E2 level. Output. The laser emission will have wavelength of 10,600 angstrom, so occur in the infrared range of spectrum. Uses or advantages: they produce continuous laser at room temperature. They can be used as portable systems since the rods are small. So ruby Is a three level laser. The output is pulse form. Here the output is continuous. They have surgical applications. They are used material processing such as drilling, spot welding, marking. They are used as pumping, tunable, visible, light lasers. They have applications in military such as including range finders and target designators. Research applications such as Raman spectroscopy, remote sensing, mass spectrometry. So these are the uses or advantages of the Nd YAG lasers. For further reference, please search our website venusscience.com. Please subscribe to our channel. And if you want a laser ebook, please email venuscience@gmail.com. Thank you and thanks a lot.